Video 47, Solving Proportions Using Cross Products and Scale Drawing and Models. Alright, to start, remember in class we talked about what a proportion is. If I have a ratio of 1 to 2 and it equals another ratio of 4 to 8, this is what we call a proportion. Alright, today we're going to learn about how cross products help us identify whether proportions are equal or to find a proportion. So here's an example. Cross products property. The cross products of proportion are equal. So for instance, if I have the proportion 5/7 and it's equal to 15/21, I can create what I call a butterfly. So I can circle these two and these two. It looks kind of like a butterfly. And I can create cross products. So if I take the ones in this wing of the butterfly, 5, and multiply it by 21, that should equal the numbers in this wing of the butterfly, 7 times 15. Right? Well, 5 times 21 is 105. And that's equal to 7 times 15, or 105. So here it is. The cross products, or the products of the two in the cross, equal each other. Alright? Here's an algebraic way of looking at it. If A over B, the ratio A over B, equals the ratio C over D, alright, it's important that B and D are not 0. Then if I multiply A times D, it should equal B times C. So AD equals BC. Alright, so let's practice this for a little bit. Alright, let's use cross products to solve this. My goal is to find out what X is. Alright, so for this particular example, if I have 2 and 7 and X and 5, I can write cross products. So 2 times 7 equals X times 5. Alright, let's simplify this first. 2 times 7 is 14, and that should equal 5x. Now, what's happening to my variable? It's being multiplied by 5. The inverse, or the undo of that, is to divide both sides by 5. So I'm going to divide by 5 and divide by 5. Alright? Five goes into here, cancels out, and I get X. 5 goes into 14 2.8 times. So that means that X equals 2.8. Alright, let's look at another example. Alright, here's a story problem. When Jake visited Canada, he exchanged $10 and he received 14 Canadian dollars. Find out how many US dollars he exchanged when he received 35 Canadian dollars. Now, when you set up a proportion like this, it's super important that you follow the same pattern. So for instance, if I start with 10 US dollars and I put it over 14 Canadian dollars, then it's really important that I do the same thing over here. On this side of the proportion, I know Canadian dollars. I'm going to put 35 on the bottom because that's where I put Canadian dollars in this proportion. I don't know US dollars. That's the question they're asking me. So I'm just going to use X for that. Alright? Now for here, again I'm going to use cross products. Alright? So I have 10 times 35 should equal 14x. Alright, 10 times 35 is 350. Oops. and that should equal 14x, right? What's happening to my variable? It's being multiplied by 14, and the inverse of that would be to divide it by 14. So I'm going to take 350 and divide it by 14, and I get 25 equals x. So Jake must have started with $25 US dollars when he got 35 US dollars. So that would be my answer. Okay, because those two are equal. All right, let's look at another example. The ratio of left-handed pitchers to right-handed pitchers on a baseball team is 2 to 5. If the team has 14 pitchers, how many are left-handed? All right, again, let's start by writing a proportion. All right, well, they have 2 to 5 right and left-hand pitchers. All right, so for this situation, I have a total of 7 pitchers. All right, we want to know how many are left-handed, so I'm going to focus on the number of left-handed pitchers, or 2. So out of 7 pitchers, I have 2 left-handed pitchers. That should be equal to, we don't know how many left-handed pitchers here, over 14 total pitchers. So here's my proportion. I should be able to use cross products. 2 times 14 equals 7L. Okay. Again, I need to undo multiplication, so I'm going to divide both sides by 7. Okay. Let's simplify this side. 2 times 14 equals 28 over 7 equals, well, I can cancel these out and I get L. If I divide this, I get L equals 4, where there were 4 left-handed pitchers. That would be my answer. All right? Okay, now let's apply this to scale drawings. What is a scale drawing? A scale drawing is a diagram of an object in which the dimensions are in proportion to the actual dimensions of the object. Right? Maps are a good example of this. Right? If I have a map from Green Bay, Wisconsin to St. Paul, Minnesota, the map is to scale for the actual distance from those two cities. The scale is how the drawing's dimensions and the actual dimensions or distance are related. A scale model is an actual model. So sometimes you might see a scale model of a building. Architects use these. And it's the actual dimensions of the actual building. So let's look here at an example. It says, use the map of Nebraska to estimate the distance between the towns of Ogallala and Central City. From the map scale, 1.5 centimeters represents 100 miles on the map. The distance between Ogallala, right here, and Central City, right here, is 3 centimeters. Okay, so write a proportion to find the distance between the two towns. All right, I know my scale is for every 1.5 centimeters on my map, it stands for 100 miles. And that's what it has right here. Okay, now I know that Ogallala and Central City are 3 centimeters apart. So up here I have centimeters, down here I have miles. Okay, I'm trying to figure out how many miles, so I'm going to make that x. Okay, and that'll tell me the distance. Again, I'm going to use cross products. So 3 times 100 should equal 1.5 times x. Right? Let's simplify this side. I get 300 equals 1.5x. Again, I need to undo multiplication. To undo multiplication, I need to divide. So I'm going to divide both sides by 1.5. Alright, this is where you can use your calculator. Alright, 1.5 goes into 300 200 times, because this is a division problem here. And that's going to give me, these two cancel out, and I get x. So it's 200 miles from Ogallala to Central City. And that's how you would use the scale on your map. Okay? Now, let's think about the dimensions on a scale model. Alright? I have a model car. The scale model of an Austin Healey automobile is for sale at the local hobby shop. The scale used is 1:5. The height of the actual car is 45 inches. Find the height of the model. Alright? First of all, let's think about how we want to write this proportion. Alright? We're going to use scale over actual. Alright? And this is a standard you want to use throughout. Alright? In this case, for every 1 of the scale, it's 15 of the actual car. Alright? The height of the actual car, and this is in inches. The height of the actual car is 45 inches. Remember, we're going to put actual at the bottom. So that equals, I don't know what the scale is, or the height of the scale, but I do know the height of the actual car. And again, these two are in inches. Alright? I'm going to use cross products. Okay. So 1 times 45 is 45 equals 15x. I'm going to undo multiplication. So I'm going to divide both sides by 15. This cancels out because that's 1. I get x equals 15 goes into 45 3 times, which means the scale model had a height of 3 inches. That's my answer. Okay. Sometimes you're looking for scale. Alright? An architect is planning a theater complex. The model that he's created is 36 inches tall. So remember, we're going to use scale, so that would be the model, over actual. So I'm going to start with 36 inches. Okay. The resulting theater, or the actual size, is 150 feet. Okay. So, what would be my scale? This is kind of like a unit rate, only on top this time I wanted per inch. Alright? So how would we find out what it is per inch? Well, this is kind of interesting because this is in inches and this is in feet. So maybe we should start by converting this to feet. Well, how many inches are in a foot? 12. So I'm going to divide 36 by 12, and I'm going to get 3 feet. So make it easier. So if we go 3 feet over 150 feet, now we have the same measurement. Alright? We're going to divide the top and bottom by 3. Okay. This will give us 1 foot on top and 50 on bottom. So for every 1 foot of my model, it's 50 feet of the actual building. Okay? And that's the end of the video on scale models and solving proportions using cross products.